Hi, I'm Shyamala Gauri, Assistant Professor, CSE in Rohini College of Engineering and Technology. CS 3491 Artificial Intelligence and Machine Learning. Unit 3 Supervised Learning. In this presentation, I'm going to explain about regression. Regression analysis is a statistical method to model the relationship between a dependent target and independent predictor variables with one or more independent variables. More specifically, regression analysis helps us to understand how the value of the dependent variable is changing corresponding to an independent variable when other independent variables are held fixed. It predicts continuous real values such as temperature, age, salary, price, etc. Regression is a supervised learning technique which helps in finding the correlation between variables and enables us to predict the continuous output variable based on the one or more predictor variables. It is mainly used for prediction, forecasting, time series modeling, and determining the causal effect relationship between variables. In regression, we plot a graph between the variables which best fits the given data points. Using this plot, the machine learning model can make predictions about the data. In simple words, regression shows a line or curve that passes through all the data points on target predictor graph in such a way that the vertical distance between the data points and the regression line is minimum. The distance between data points and line tells whether a model has captured a strong relationship or not. Some examples of regression are prediction of rain using temperature and other factors, determining market trends, prediction of road accidents due to rash driving. The types of regression are shown here. There are eight types of regression. One is linear regression, two polynomial regression, three support vector regression, four decision tree regression, five random forest regression, six ridge regression, seven lasso regression, eight logistic regression. Here we are going to see about linear regression. Linear regression is a statistical regression method which is used for predictive analysis. It is one of the very simple and easy algorithms which works on regression and shows the relationship between the continuous variables. It is used for solving the regression problem in machine learning. Linear regression shows the linear relationship between the independent variable x-axis and the dependent variable y-axis, hence called linear regression. If there is only one input variable x, then such linear regression is called simple linear regression. And if there is more than one input variable, then such linear regression is called multiple linear regression. Bayesian linear regression allows a useful mechanism to deal with insufficient data or poor distributed data. It allows user to put a prior on the coefficients and the noise so that in the absence of data the priors can take over. A prior is a distribution on a parameter. If we could flip the coin an infinite number of times, inferring its bias would be easy by the law of large numbers. However, what if we could only flip the coin a handful of times? Would we guess that a coin is biased if we saw three heads in three flips, an event that happens 1 out of 8 times with unbiased coins? The MLE would overfit these data, inferring a coin bias of P is equal to 1. A Bayesian approach avoids overfitting by quantifying our prior knowledge that most coins are unbiased, that the prior on the bias parameter is peaked around 1 off. The data must overwhelm this prior belief about coins. Bayesian linear regression. Bayesian methods allow us to estimate model parameters to construct model forecast and conduct model comparisons. Bayesian learning algorithms can calculate explicit probabilities for hypotheses. Bayesian classifiers use a simple idea that the training data are utilized to calculate an observed probability of each class based on feature values. When Bayesian classifier is used for unclassified data, it uses the observed probabilities to predict the most likely class for the new features. Each observed training example can incrementally decrease or increase the estimated probability that a hypothesis is correct. Prior knowledge can be combined with observed data to determine the final probability of a hypothesis. In Bayesian learning, prior knowledge is provided by asserting a prior probability for each candidate hypothesis and a probability distribution over observed data for each possible hypothesis. Bayesian methods can accommodate hypotheses that make probabilistic predictions. New instances can be classified by combining the predictions of multiple hypotheses weighted by their probabilities. Even in cases where Bayesian methods prove computationally intractable, they can provide a standard of optimal decision making against which other practical methods can be measured. Uses of Bayesian classifier. It is used in text-based classification for finding spam or junk mail filtering. It is used in medical diagnosis. It is used in network security, such as detecting illegal intrusion. Thank you.